Transformations question, and the first thing you're asked to find is what sort of transformation takes triangle P onto triangle Q. Now, to get from P to Q, it's definitely not an enlargement because it stayed the same shape. It's not a translation because P and Q don't look the same. Q is actually flipped over. So it could be a rotation or it could be a reflection. Now, what I'm going to do is show you that it's not a rotation, because if I take, I'm just going to rotate this. If I try to rotate, well, actually, let's do it as P onto Q, P onto Q. If I try to do it by rotating, you can see that if I just do it by rotating, P is never going to fit on top of Q. So it's definitely not, oops, let's just rotate that back in. It's not a rotation, which means it must be a reflection. So let's try and find the reflection. Let's just put that back in position. Let's try and find the reflection. I can see that the line of reflection is going to be somewhere along here because P has flipped over to here. So the line of reflection is going to be somewhere there. Let me just draw it on for you. So basically the line of reflection, or the mirror line, is going to be this along here. Because if you look at what's actually happening, I can take each corner. So let's say, for example, I take this corner of P. Well, let's take this corner first. I can see that that corner is exactly the same distance the other side of the mirror line. Okay, you've got 2.5 squares here, 2.5 squares here. If we look at this corner here, the bottom left, the bottom right-hand corner of P, it's moved to there. So it's gone 3 diagonal squares. And this corner, the top corner of P, has gone over to there. Now, how do we describe that reflection? Well, this line here, every point on this line has coordinates. Let's look at the coordinates of this point here. These coordinates are 5 minus 5. This point here, for example, is 3 minus 3. This point here is minus 5, 5. So the equation of that line is actually y equals minus x. The y number is always the minus version of the x number, and vice versa. Another way, well, you should know the equation of this line anyway. Another way of thinking of it is, you know that every straight line has equation y equals mx plus c. The gradient in this case is negative, obviously, so it's 5 divided by 5, which is minus 1. So you've got a line which goes down like that, where that's 5 units and that's 5 units. The gradient of that line is negative, and it's 5 over 5, which is minus 1. So the gradient is minus 1. The intercept of the line is actually 0. So the equation of the line is y equals minus 1x plus 0. Well, that just simplifies to y equals minus x as before. So to describe that reflection exactly, first of all, you need to use the word reflection. And then the equation of that line, it's a reflection in y equals minus x. Remember, you look at your reflection in a mirror, so don't use any other word here apart from in. Okay, the question now says, and I'm going to just get rid of everything here. I'm just going to undo everything. The question then says, what is the single transformation that takes, oh no, sorry, it says rotate triangle Q through 90 degrees anti-clockwise. So let's just get rid of that. So we're going to rotate triangle Q through 90 degrees anti-clockwise about this point here. And I'm going to attempt to do this by rotating the shape that I have cloned. Okay, so I'm going to rotate 90 degrees anti-clockwise. So that's in this direction. Now, notice it's quite hard for me to get the center of rotation in exactly the right place. So I'm going to rotate it and then put the center of rotation in the right place. You can see the center of rotation is not quite, oops, it's not quite in the right place. So I'm going to move the whole thing so the center of rotation does line up. There it is, there's the center of rotation. So you can see that Q has moved from there to over here. So in fact, this is my R, and the coordinates of R are, you can see this is the original axis across here, and there is my shape R. Okay, the coordinates of R are 2 minus 1, and then you've also got 3 minus 1, and then 3 minus 3. Not particularly clear on mine. Okay, let's just undo all of that lot. Right, next thing it asks me to do is describe the transformation which maps P onto R. So I'm just going to get rid of my cloned version there. Where are we? Let's just get rid of that one. So delete that one. So there's my original. Okay, R is over here. If we just draw R in, it was there, wasn't it? So here is my R, and then down like that, oops, and here. And the question says, what is the transformation? So there's my R. What is the transformation that takes P onto R? And I can see again, it's quite an easy reflection this time. It's a reflection in a line which goes horizontally across here. So here's the mirror line. And the equation of that line is y equals 1. Remember, the x-axis has equation y equals 0. So this is the line y equals 1. In other words, the single transformation which maps P onto R is a reflection in y equals 1.